The past several lessons have been about us finding intervals where a function is increasing or decreasing, or points of inflection, or when we found maxes and mins, we've always found relative mins or relative maxes. And this lesson is supposed to be about absolute extrema, absolute maxes and absolute mins. So the absolute highest point and the absolute lowest point on a curve. And there's a theorem about this that helps us define how to do that. And the theorem is this: if you've got a function that's continuous and that's big, if it's continuous on a closed interval from a to b, and by the way, the reason it has to be continuous is that if it's not continuous, it might have an asymptote. And if you've got a graph that has an asymptote, a vertical asymptote in the middle of it, any chance of finding an absolute max or an absolute min is gone, because the graph can go up forever and the graph can go down forever. So we need the function to be continuous. If it's continuous on a closed interval, it will have an absolute minimum and an absolute maximum. And further, we know that we can always find that max or min at either one of the critical numbers, which is where the derivative is 0 or undefined, or one of the endpoints of the interval. And so that's sort of the deal. That's what they are. This is the idea that we're going to be going with. Now, there is an important thing to note about this, and I know there's a lot going on this page. Give me just a minute. The maximum and minimum of a function are actually the y values that are achieved. So, like looking at this picture down here, and actually I'm getting ahead of myself. It's not possible for a function to have more than one maximum or more than one minimum. And I may want you to read that again. It is not possible for a function to have more than one maximum value. The function might achieve that maximum or minimum value more than once, but it only has one maximum. And so I have an example here that I hope will make that clear. Suppose that I give you this function over here, f, and I want you to find the minimum and the maximum of that function between 0.5 and 4.8. So 0.5 is like here, right? And 4.8 is over here. Right? Great. So what's the maximum of this function? Right? We said that the maximum is going to happen at the endpoints of the interval or critical numbers. So it's sort of like maybe it's this guy, maybe it's this guy, maybe it's this guy. Well, rather clearly, this is the highest point. That means that the maximum of this function is, 3.6 about. What about the minimum of this function? And somebody might say, oh, well, to me, this function has two minima. And I would say, yeah, I disagree. There are 2 points where you reach the minimum, but what is the minimum, the one and only absolute minimum of this function on this interval? Well, both of these points reach a low value of -1, and so our minimum is -1. And again, note, I don't have two minima here. There's one minimum value, it's -1, and that is achieved twice on the interval. Okay. In the next slide, I'm going to go into what the steps are that we use to actually do this for real problems. So the steps to find the absolute extreme on a closed interval, there are basically 4 steps. Step 1, make sure the function is continuous in the interval. If it's not, all kinds of wacky things can happen, because as soon as you've got an asymptote, like, you're kind of out of luck. And let me draw you a quick picture of that. If you've got an asymptote, the concept of finding a highest point is impossible because there's an asymptote, and finding a lowest point is impossible because there's an asymptote. So if your function isn't continuous, these problems get a lot more complicated. And for that reason, they tend to ask these questions as with continuous functions. Step 2, find the critical numbers of the function. Great, yay. Step 3, and actually I should mention, so find the critical numbers of the function. That should be where the derivative is 0 or undefined. Kind of had to squeeze undefined in there. So where the derivative is 0 or undefined is not just one or the other. You need to look at both. Step 3, we take the critical numbers that we just found and the endpoints of the interval, both of them, and plug them into the function. In step 4, just look at all the numbers you got back. Whatever the largest number you got back was, that's the absolute maximum, and whatever the smallest number you got back was, that's the minimum. That's it. That's how you find absolute extrema. It's as simple as that. I've got one example, and so we're going to look at that next. So I want us to find the absolute maximum and minimum of this function on that interval. Step 1 is supposed to be make sure that it's continuous, right? So step 1, there is no division by 0. So we're basically good. I mean, with a standard looking function like this, the only thing that really causes discontinuity is division by 0. The other big one is piecewise functions, but this isn't a piecewise function. Step 2, we're supposed to find the critical numbers of this function. At this point, everybody should be able to find the critical numbers of that function. So pause the video right now and find those before I go on. So now I'll say f prime of x equals, and I'll say, no, seriously, did you pause the video and find them? It's a very easy thing, and I just want to make sure we can all do it. So the derivative of this thing is 6x squared minus 6x minus 12. I set this equal to 0. I can factor out the 6 and get x squared minus x minus 12. And then that factors further as x minus 2, x plus 1. So my critical numbers seem to be 2 and negative 1. So great, that I've got my critical numbers. In step 3, I'm supposed to take my critical numbers and the endpoints of the interval, which are negative 2 and 4, and plug all of them back into the original function to find out what those values are. Right, so when I do that, f of 2, so when I plug 2 back into this original function, f of 2 is negative 14. F of negative 1 is, and I worked these out ahead of time so that you wouldn't have to watch me fumble through arithmetic right now, is 13. F of negative 2 is, so your negative 2 was 2, and f of 4 is 38, right? So looking at these numbers, we now sort of go on to step 4. Step 4 is where we decide, okay, great, what is the absolute minimum, what is the absolute maximum? Of these 4 numbers, it looks to me like negative 14 is the absolute minimum on this interval, and 38 is the absolute maximum. Right? Notice that one of these happened at an endpoint of the interval, and the other one happened at one of the critical numbers. So it's not like, I said that the absolute max and min are supposed to happen at the endpoints of the interval or critical numbers. It's not like it's going to happen where both of them will be the endpoints or both of them will be the critical numbers. You might have one of each. Or you might have 2 of the same. A number of different things can happen. But this process will allow you to find the absolute max and mins every time. These problems do get a little bit more complicated on the AP exam, and when we get into the second half of Chapter 3, I'll sort of cover how we have to deal with those things. But for now, this is how we find absolute maxes and mins. So hop on over to the assignment, try out a few of the problems, make sure you've got the idea, and then enjoy the rest of your day.